Good afternoon, or good morning rather, and welcome to our number 10 and the final of our Connect and Learn webinars, hosted by Turning Point, funded by the Department of Health and Human Services. Welcome today, and thank you so much for joining us live for this final webinar for the year. Today's webinar is called What's Cooking? Methamphetamine and Cognition. And I'm joined here today by two incredible neuropsychs who work for Turning Point, and I'll introduce them both in just a moment. But first, to just pause, I wanted to acknowledge the traditional custodians of the land that we meet on today, where we work and where this recording is taking place, and acknowledge the Wurundjeri people of the Kulin Nation. We'd like to all acknowledge and pay respect to their elders, both past, present and emerging, and the elders of any other Aboriginal communities as well. So thank you so much for being with us live today. We're very excited for this topic, and we've had a lot of people register for this one quite quickly. So we're very aware that it's a topic that is something that clinicians are really interested in, and people who work with those people in the community to get more information and to be able to do really good work. So thank you for being here. So as I said, the Connect and Learn webinars are funded by the Department of Health and Human Services, and they are for people who work in the AOD sector across Victoria, but very often we get people outside Victoria as well. So just to remind you that this webinar goes for 45 minutes, and during the webinar there will be times for questions. So there's going to be Q&A sections. You'll notice there's a chat box in the bottom left-hand part of your screen, side of your screen. You can, even though there'll be points at which there are Q&A sessions, you can go ahead and type your questions in there as we go along. So feel free just to pop questions in there, and my job today is to monitor those questions and make sure that they get fed through to the presenters. There'll also be a couple of polls, so look out for those, and at that point you can participate in answering the questions that the presenters are asking, and you'll get the feedback immediately in real time about what everybody else in the state has answered to those. So we know that people get the most out of these if they participate, so go ahead and type your questions in and participate in the polls. The other thing to know that is you have a folder in the bottom right-hand corner of your screen, and we will be uploading the PDF version of these PowerPoint slides. So you can, if they're not there yet, they will be by the end of the presentation. So you can download the PDF of the PowerPoints, and then you can refer to those later on. So, so you can do that. Alrighty, so I think that's all the housekeeping. If you do have any technical problems, Redback are here to support you. Go ahead and type those into the chat box as well, and what you'll see is that Redback will come back and answer your queries that, around anything that's technical. So if there's sound issues or visual issues that, that are happening, just go ahead and pop those in there. And there's also a phone number at the bottom of your screen as well, which you can call in if you wanted to talk to somebody at Redback, and they'll support you there. I wanted to now go ahead and introduce the two presenters that we have with us today, and we're really lucky to invite back Dr. Catherine Cox, who was actually the person who kicked off our webinar series in February and was here to do the inaugural webinar. So we welcome her back, and very grateful for her to bring her time and her skill and expertise. And with her is Dr. Vanessa Peterson. So both Dr. Catherine Cox and Dr. Vanessa Peterson are neuropsychologists with Turning Point and have extensive experience working in the AOD sector and people who use drugs and alcohol. So the topic today, which is about methamphetamine and the impacts on cognition and the brain, will be supported by the latest discussions around the latest research and the limitations to that research, as well as some case studies and also some tips to clinicians as well for working with their clients. So I would like to go ahead and introduce Dr. Catherine Cox and Vanessa Peterson, and thank you very much. I'll hand it over to you now.
Great, thank you, Sheridan. So today, as you know, we're going to be talking about ice and cognition. So it would be very hard to miss the research, and also especially what's been in the popular press about ice and the epidemic of ice that we're experiencing at the moment. But I guess what's interesting for us particularly is, does ice affect your brain and what happens to your thinking skills when you use a lot of ice? So we have a poll and some questions which will pop up in a minute. So we're going to ask these questions now, and we're also going to ask these questions at the end. So it's a little bit of an opportunity to test yourself. So here they are. So the question is, does methamphetamine cause lasting cognitive impairment? So we've got 1 for not sure, 2 for yes, and 3 for no. So pop your answers in. We'll leave that for another 10 seconds. Everybody had a chance to put their details in? So it's looking like a lot of people think yes. Some people are not sure, and 3 people, or not very many people, think no. So thank you for that. So we'll have an opportunity later to test yourselves again. So first of all, we're just going to set the scene and give you a bit of background information about methamphetamines. Starting off, to explain what a neuropsychologist is. So, contrary to popular belief, we can't read your brain. It's a major sort of party stopper to tell people that you're a neuropsychologist. What we are is psychologists with either a master's or a doctorate in clinical neuropsychology, and our specialty is dysfunction in the brain. And there's actually 3 of us in our team, but today you're seeing Vanessa and myself. So first of all, we're going to talk throughout our presentation today with a few case studies as well to illustrate the kinds of people that typically get referred to us at Turning Point. So our first client is someone that we've called Simon. He's a previous daily methamphetamine user. He's been abstinent for about 6 months. He's got quite a lot of mental health issues, a past history of assault, and the referral says that, he forgets things. He forgets to attend appointments, he loses his wallet, he loses his keys, he can't learn names. And he seems to have some difficulties in everyday life. So the questions are, does he have an acquired brain injury or an ABI, and how can the referrer support the client? So what is an acquired brain injury? Let's start at the beginning. So an acquired brain injury is any injury to the brain that occurs after birth, and the reason for this can range from a traumatic brain injury to substance abuse or toxins or to stroke. So anything really that happens after you've been born. And what we really look for is a reduction in functioning from the level that the person would have been at before their injury to how they are now. We want to try to show that what's happened to the person has injured their brain and caused a change in function. So, for example, if the client who's referred to us was a lawyer and then they had a stroke or something happened to them and we're trying to determine whether they've had a brain injury, we do a whole range of different tests to try to understand where the person would have been functioning before based on their test performance and also their educational and their occupational history. And from that, we then determine whether there's been a reduction in function. So someone who's a lawyer, where you might have different expectations compared to someone who, maybe hasn't had much schooling and, has struggled to work. So neuropsychologists take all of this into account. So going back to Simon could have an acquired brain injury or some cognitive impairment, but there's a good chance that it's not due to his past methamphetamine use. There might actually be modifiable risk factors that you could address today to help Simon with his thinking skills. Isn't that great news? There might in fact be other things that led to his impaired cognition, so it's not all about the methamphetamines. So this is something that, we want you to keep in the back of your mind. This could be the case. We just need to have, I guess, a better think about it. So what we thought we'd do today is contrast methamphetamine to alcohol. So we have a lovely picture of a martini here. And we know that alcohol has been consumed by humans for at least 10,000 years. So there's documented literature of people making alcohol and drinking it for thousands of years. And we know that it's really quite impairing to your brain. So we have a quote there on the page from someone who's considered the grandmother of neuropsychology, Muriel Lezak, who said that, it's probably one of the most devastating and widespread neurotoxins the world over. So alcohol-related brain injury is also a very well documented phenomena, and we know that alcohol is neurotoxic, and it's neurotoxic via a range of mechanisms, which include thiamine deficiency. So those of you who work with clients who have used alcohol know that they're often given thiamine tablets, they often don't eat. Alcohol increases the metabolic stress in your body, your blood flow changes, and there's other things as well that happen to your body secondary to alcohol abuse that affect your brain. So we know that from a neuropsychological point of view, when we test people who drink too much, they have problems with executive functioning and memory. If people are abstinent, then they can improve in their cognition, but for some people, if the damage is too great, then they really don't improve. So it's a very lasting kind of a brain injury. Where does the brain change? We know this as well. It changes in the memory parts of your brain, in the front part of your brain, and the back part of your brain. And in fact, for people who have a significant alcohol history, then their whole brain can atrophy or shrink. We know as well that there's a clear dose-response effect. So for people, the more you drink, the more brain damage you sustain. So it's a very clear relationship. Okay, so we jump back to methamphetamine. So at the very top of the slide, you can see that the disease or injury burden of methamphetamines is 0.4%, whereas for alcohol it's 4.6%. So looking at methamphetamines and what it does to you, because that's what we're here to talk about today, you can see that a lot of the burden is from dependence. People have accidental poisoning, there's suicide and self-inflicted injuries, and also road traffic injuries. So you can see the sorts of things that happen there. So let me see. Here we are. So we know too that the use of methamphetamine within our community is increasing. So the deaths involved with methamphetamine use are actually 4 times higher in 2016 as compared to 1999. So it's definitely a more commonly abused drug these days than it was before. You can also see here that hospital separations, or when people leave the hospital that are, attributable to methamphetamine admission, you can see that increasing as well. So, people are presenting much more to hospital now than they were in the past. And in fact, it's higher than a lot of the other substances listed on the graph. So in terms of the use statistics, what I want to point out to you here is that a lot of people, let me see, I can use a little pointer. So what I want to show you here, this is the frequency of use. So people use methamphetamine in different ways, and if you think to the clients that you work with who use meth, then you'll be able to understand this slide. So by far, most people use it once or twice a year. Some people use it every few months. People use about once a month, and then there's a smaller number of people who use it daily or weekly. So this is, your typical kind of, I guess, user. So you can see that there. Oh, there was a box. Here we go. So what does methamphetamine actually do to you? Sorry, we've just got a little bit of things in the background. So what happens when you use methamphetamines is that you become very euphoric, you feel increased amounts of energy, you feel alert, you're more excitable, your heart rate goes up, you're sweating, you're dizzy, you're restless, you can't sleep, you grind your teeth, and you can talk a lot. So people do feel pretty good when they take methamphetamines. What we know about cognition is that when you take methamphetamines, you have faster reaction time, you can concentrate better, but you do tend to make more mistakes, and your ability to inhibit yourself or control what you're going to do reduces. And if you think to some prescribed amphetamines like Ritalin, which are given to people with ADHD, we know that your cognition improves when you take smaller amounts. So this is an example of another referral that we may get to our team. So Jenny comes to us, and the question is, does she have an ABI? So we get the referral for Jenny, and we look at it. So Jenny smokes methamphetamines every weekend, sometimes during the week. She sometimes injects. And what we know about her is that she's still working full-time, she's university educated, and when she's not using methamphetamine, she uses benzodiazepines to sleep, and she also is a regular drinker. So at night, she'll have 3 glasses of wine each night. Now, we know that your typical methamphetamine user doesn't just use methamphetamines. People will use methamphetamines, and then to manage themselves, as they're coming down, they'll often use other drugs. So they might use cannabis, they use benzodiazepines to help them sleep when they're not using meth. So Jenny complains of poor memory and problems concentrating. And when we get the referral, well, does Jenny have an acquired brain injury? And we think about this and we think, well, she hasn't used, methamphetamines for a very long time. She's got about a 3-year history of use. She's still working. There's other things in her history that could be causing her poor memory and her problems with concentrating. So our feedback to the referrer is that time spent with Jenny working on her other substance use, her sleep hygiene, addressing some of the harms associated with her use are likely to help her with her cognition and are probably causing her cognitive difficulties. And if we can address these, they're modifiable reasons why she'd be having the cognitive problems that she is. It's very unlikely that her pattern of methamphetamine use is what's causing her difficulty. So what happens to your body when you use methamphetamines? So some of this information I'm going to share with you now does come out in the media. So we know that you get high blood pressure when you use methamphetamines. Your blood vessels constrict, your pupils dilate. There's quite a lot of cardiac side effects to methamphetamines, and so you can become have a very high heart rate, which is tachycardia. You can have also damage to your heart, and people become quite hot. So you can become really very hot, and this is one of the reasons that people can die after taking methamphetamines. So methamphetamines can stay in your body for 4 to 6 hours, and maybe around 4 to 8 hours people will experience the effects of methamphetamines. And if people use in a party or club or festival type environment or on a really hot day outside, then this will increase the risk of people becoming overheated. So one of the things that does happen with methamphetamines, and this is of interest to neuropsychologists, is that when you use, your stroke risk is increased by about 4 times that of non-methamphetamine users. And in the medical literature and in the hospitals, there are people who present who are young who have strokes related to their drug use. So why might this happen? So one of the things is that using methamphetamines can cause inflammation of your blood vessels or a vasculitis. People might have existing abnormal bundles of blood vessels in their brain, which is an aneurysm or an AVM, and when your blood pressure goes up, these can rupture. It's more likely to cause you to bleed into your brain. Your blood pressure can go up quite a lot, and this can be a problem as well and a risk factor for stroke. And it also does present a lot of difficulties for pregnant drug users having this sort of increased blood pressure. So this is definitely, one of the risk factors associated with using methamphetamines. So what happens when you use? So we have a picture here that sort of summarises, I guess, the potential consequences of using methamphetamine. So you can have a hypertensive crisis where your blood pressure is very high. We haven't talked about the psychiatric side effects, but people do become quite paranoid. You have cardiovascular stress. It stops you sleeping. So people tend to binge use, and they'll use over a period of some days and they don't sleep very well at all. And the longer you don't sleep, the worse sort of things become for you. You can end up with your muscles breaking down, which is rhabdomyolysis. People can engage in a range of risky behaviours, which are written down there. There's the side effects from grinding your teeth. And some people can present with heart attack, or they can think they're having a heart attack because they can get chest pain and their mouth will be very dry. So there's a whole range of different things that we know happen when you use methamphetamines. So after that sort of, I guess, acute phase, then there's this 2 to 4 days after people have used where they're also really not quite right. So they're in the kind of coming down phase. So they can be very tired. They can either be wide awake or they can be very sleepy, flat, anxious, paranoid, having hallucinations, being irritable and having mood swings. And, you know, if you came to see me for an assessment at this particular point in time, I'm sure you wouldn't perform very well. So one of the things we want you to think about today are some of the cognitive difficulties or thinking problems that you see with your clients related to the acute use? Is it that they're high or is it that they're coming down? And what about the other things that they're using at the time they're coming down? So this can be a cause of the cognitive difficulties that people are having. So then you have withdrawal, and this can continue for up to 4 weeks, with people being anxious, having trouble concentrating, wanting to use the drug, feeling quite depressed and flat or feeling very anxious. And again, you know, if you're super anxious and all you can think about is the drug that you wish that you were using, then again, you know, your cognitive performance won't be at the best. You know, we all know that when we're really stressed or we're tired, or we're worried about stuff, or we've got things in the back of our mind, that we just don't do very well. So this is another example of someone who, you know, is typical of the referrals that we get. We've called him Marco, and he's referred to us because, as I'm sure a lot of you know, we're trying to get people onto the NDIS. So he's referred to us. And again, people are wondering, you know, does he have a brain injury? So in terms of Marco's history, he's using 1 to 3 points of ice nearly every day. He's using marijuana of about 1 gram each night. His history is notable for past child sexual abuse. He left school when he was in year 8. He didn't really like school. There wasn't anything he was particularly bad about, but, you know, he just didn't enjoy it. He presented with a history of being very anxious, being paranoid, and he had a history of drug-induced psychosis as well. So his worker said, look, you know, he needs reminders and transportation to attend appointments, or he just doesn't come. He's had periods of homelessness. His nutrition isn't great, and when he gets distressed, then he becomes really quite quickly agitated. So we brought him in for an assessment with us. So this is what we found. When we assessed Marco, we thought that he was low average intellectual ability, and we thought that this was probably about where he would have been for a long time. And most of his abilities fell in this range. The only thing when we tested him that was actually impaired was his attention. His concentration really wasn't that great across the assessment. He was quite distractible, and on the more formal measures of attention that we used, he didn't do as well. He also presented as being very paranoid and anxious. So throughout, you know, the assessment, he was worried, he asked questions, and, you know, it was clear that he had some paranoid ideas about people watching him and being sort of overly interested in him. So when we wrote the report, what we thought was that Marco actually has these long-standing weaknesses. This is not a new pattern of performance for him. The vast majority of his skills are within that range, in the low average range where he would have been before. He is currently still using, and the other thing is he has a lot of mental health difficulties which can easily account for his poor attention. So on balance, we think he probably doesn't have an acquired brain injury. But rather we want to address those other modifiable risk factors that can be affecting his cognition. So I'm going to hand over to Vanessa now, who will cover the next part of our presentation with you, asking, is methamphetamine actually toxic to your brain and damage your brain?
Okay, so we'll shift gears a little bit and talk about neurotoxicity. In terms of neurotoxicity, I've been having a look at the research lately because I'm presenting this webinar and we're presenting the research to you. And what we've discovered is that the research is really hard to untangle. There's lots of holes in the research. So some of them are up here, we've got different measures used across the studies. So that might range from cognitive tasks to other measures if we're looking at laboratory animals, the way that they look at the brain and stay in the brain and that sort of thing. What we also see, and this one's really important, is that the studies might show statistically significant differences, but does that statistical significance actually translate to functional damage in day-to-day abilities and thinking skills? The other important thing that Catherine touched on is that the problems might have actually been there before the methamphetamine use started. So whether that's low premorbid ability, or whether there are other issues such as mental health factors like we saw with Marco. And these factors certainly can predispose methamphetamine use. There's just no accounting for what the person was like before they started using methamphetamine. Okay, so an important variable that is completely inconsistent across studies on recreational users is individual client variables that we see in the studies. So we've got polydrug use and different substances that are used across the studies. People use different quantities of substances. They have used for different periods of time. So their substance use history certainly differs in terms of duration of time. The route in which users take methamphetamine will have an impact on neurotoxicity. So if we think about intravenous use versus smoking versus consuming, which we know has the least neurotoxic effects. Their mental health history, such as depression or anxiety, might impact the results. And of course, alcohol and other substance use. We're going to talk a little bit about how methamphetamine works in the brain, because we're going to move on to talk about neurotoxicity, and I don't want people to get overwhelmed with this slide because it is a little bit intimidating. What we see here is a presynaptic cell in the brain. It's a neuron. And what we know with methamphetamine is that it actually acts on the monoamine, so dopamine, serotonin, and noradrenaline. But with this talk, we're going to focus on dopamine because that's the most prominent target of methamphetamine, and also that most of the neurotoxicity research looks into dopamine. So what happens when someone takes methamphetamine? So methamphetamine actually basically promotes the release of stored dopamine. So dopamine are the little blue dots you can see on the slide here. So it promotes the release from the presynaptic terminal, which is this blue part up the top here, into the central nervous system, into the presynaptic cleft here. And it also prevents reuptake of dopamine by blocking and reversing the dopamine transporter, which is this little purple thing here. So it prolongs the action of dopamine on pre- and postsynaptic receptors. And the metabolism of dopamine is also prevented by the administration of methamphetamine. And we know that dopamine is really important for many human cognitive, so thinking skill and motor functions. So that's why the use of methamphetamine is really important to consider. How do we define neurotoxicity? It's a good question because different authors define it in different ways, and I've just put up a few of the definitions there. So some of the papers state that neurotoxicity is persistent adaptive changes in gene expression or protein function in the absence of neuronal death. Others actually specify that there needs to be neuronal death, as you can see in the top box there. And then other authors suggest that neurotoxicity is associated with neuroanatomical changes, functional neurotoxic changes, including neurophysiological and behavioural effects. If that sounds really intense, hopefully it'll make a bit more sense as we go on the next few slides, but we're not going to get into the neurophysiological stuff too much. But what we want to know is, as neuropsychologists, and I guess for people who are working with methamphetamine users, is do these changes that we're seeing in the research, in brain cells or in brain scans with humans, do the changes result in impairment of clinical significance that we can actually observe in everyday functioning? So in other words, do they have an acquired brain injury or cognitive difficulties? We're not going to go into this slide in detail, just keeping it really brief, but the mechanism by which methamphetamine causes neurotoxicity is hypothesized to be due to an interaction between a number of things. So we've got things like hypothermia, oxidative stress, we've got toxic metabolites, neuroinflammation, and high cortisol levels. So a whole host of things interact to result in neurotoxicity. How do we actually evaluate neurotoxicity? So we can do it, namely, we're going to talk about 3 ways today. So we can look at biochemical factors, so brain neurotransmitters. That can be directly measured in lab animals. So we can look at brain staining techniques. We can measure the levels of monoamines and metabolites. Transporter binding sites. I mentioned in the other slide earlier that the dopamine transporter is reversed and influenced by having methamphetamine. And we can look at the expression or activity of enzymes that are involved in the synthesis of making dopamine. But obviously that's in the synthesis of making dopamine. But obviously that's a lot harder in humans. It would need to be done post-mortem, or we can do brain scanning. So we can look at SPECT or PET scanning to look at the neurotransmitters. The other thing that we can look at is neuropsychological functioning. So that's performance on validated tests of cognition and thinking skills. But first, let's start with laboratory animals, where we can directly actually measure the effects of methamphetamine. And what we generally see in the literature is deficits in dopaminergic functioning in lab animals. So we've got decreased dopamine, decreased dopamine transporter density, and also we see that tyrosine hydroxylase is decreased as well. And this is the rate-limiting enzyme of dopamine, so basically what breaks down dopamine. And we see these changes mostly in the striatum, but other areas of the brain too, cortex, hippocampus, hypothalamus, and thalamus. These changes are dose-dependent, so the more methamphetamine that is administered, the bigger the changes that we see. But I thought it was really interesting that the loss of dopamine actually appears to recover, or in some studies partially recover in as little as 1 month, although the results do vary across studies. The problem with laboratory studies is they're not really equivalent to what we see with human recreational methamphetamine users. So a lot of the animal studies are criticised for using large doses of methamphetamine and using an acute dosing regimen. So you might see a lab animal suddenly exposed to a huge dose of methamphetamine with no prior exposure. And in fact, studies have adapted and introduced slowly escalating doses over time. And I thought it was really interesting that slowly escalating doses is actually protective against neurotoxicity. We've touched on the differences in human studies earlier. So in humans, things that influence the outcome is the polysubstance use, the route of administration. Humans will often engage in multiple doses throughout the night. And importantly, there are pre-morbid or pre-existing cognitive difficulties in human studies. And in fact, who is the control group in the research and is it representative?
Okay, apologies for that everyone, we just had some brief technical difficulties. And just to reiterate again the importance of studies which might show statistical significance, but does that actually represent day-to-day cognitive difficulties? So we shift to humans now and talk about brain imaging first. A meta-analysis was conducted in 2017 by Ashok and colleagues, and they compiled 31 studies with a total of 519 users and 512 controls, so pretty significant sample size in the meta-analysis. And these users were using stimulant substances, so cocaine, amphetamines or methamphetamine. The abstinence period in this study varied from 5 days to 3 weeks. So in some cases, the abstinence was quite short. The conclusion, though, was that stimulant users had generalised reductions in their dopamine system compared to healthy controls. And in the meta-analysis, there was some evidence that this can continue for up to 9 months post-testing. So the take-home message from this meta-analysis is that there's a mixture of pre-existing reductions in dopamine receptor levels that actually precede and predispose the onset of stimulant misuse, which are further then reduced during stimulant use. So if we think back to the case that we presented earlier, Marco, who came to see us in the clinic, he had a number of mental health difficulties. There was a trauma background. There were lots of factors in Marco's life that are likely to have predisposed him to stimulant use, which then are likely to have had some impact on his cognitive function and attention difficulties. Neuropsychological studies are studies that look at thinking skills, and we're going to focus on 3 today. 3 reviews and meta-analyses. So we've got Hart and colleagues from 2012, Dean from 2013, and a more recent paper that has become to be cited quite commonly is Potvin in 2018. Okay, so the Hart paper wanted to answer the question whether methamphetamine causes acquired brain injury, and is it actually relevant for individuals day to day. And in order to answer that question, we really need to have a think about the bell curve and what the average range means. So most of the population, if you think about percentiles, 100% of the people will fall within the bell curve, and the average range ranges from person at the 25th percentile to the 75th percentile. So there is actually a wide range that you can fall into there, which is considered the normal range. So if someone was performing at the 25th percentile, they're considered average, and if someone's performing at the 75th percentile, they're considered average as well. So I guess what we need to answer is day to day in a everyday functioning capacity, will we see differences between those 2 people? And Hart argues that studies might show statistical significance, and that might translate to something like someone at the 90th percentile versus someone at the 100th percentile. So we might not actually see differences in their everyday functioning. We're just presenting a few of the results from the various papers here. So Dean and colleagues suggested that methamphetamine users are likely to have pre-existing cognitive deficit, so their pre-morbid ability is different. Hart suggests human lab data shows improvements in cognition or thinking skills with small doses, so we know that Ritalin and other prescribed amphetamines do result in improvements in cognition. And Dean and colleagues suggest that methamphetamine abuse causes cognitive decline in at least some people, probably on the more mild end, depending on what moderator variables are included in the research, so things like age and genetics.
So moving on to POTBN, the most recent meta-analysis, they had a significant sample size and looked at 44 studies. There were some limitations to the research that, as neuropsychologists, we were quite concerned about. And number one is that they didn't actually control for abstinence. So of their 44 studies, only 14 of them actually recorded the abstinence. So a lot of the results in the POTBN meta-analysis are actually for current methamphetamine users, and we know that current use has significant effects on cognition. It didn't even control for mental health background of participants, their pre-morbid intellectual functioning, so educational and occupational level, and they also didn't control for other substance use either. So some major limitations to the study. But what they did find is that there were large deficits in reward and impulsivity. And they actually found only a few studies looked at social cognition, but there were impairments in social cognition in methamphetamine users compared to controls. We saw moderate deficits in attention and concentration, executive functioning, language skills, learning and memory in the verbal domain, and visual memory and working memory. And on the small end, we've got their speed of thinking and visual spatial, so reasoning with visual image information difficulties. Some of the limitations the authors did note really ties into what we're trying to say today. So moderate effect sizes don't necessarily mean the individual is functioning outside the normal range. Importantly, we need longitudinal research to see what deficits might actually be pre-morbid that were occurring beforehand versus the result of methamphetamine use. And of course, things that we mentioned earlier is the length of abstinence. There's always a publication bias that needs to be accounted for in meta-analyses, in that it's usually studies that find significance that are published. So that's always a limitation to meta-analyses. Does methamphetamine cause acquired brain injury? Well, the jury is kind of out on that. Dean and colleagues note simple linear models of methamphetamine abuse and cognition are really unlikely to capture that interplay between methamphetamine abuse and this developing adaptable organism. Hart and colleagues suggested that the apparent link has been widely publicised, but it's not really supported by the research. And POTBN did reinforce that longitudinal studies need to be conducted so that we can take pre-morbid functioning into account, as well as after long-term abstinence, which is an important thing to consider with methamphetamine use. So, to wrap it up, what do we take away from this? There are certainly serious complications that can cause brain injury in methamphetamine users, and Catherine went over some of these earlier. So we're thinking about stroke and cardiac events, but also risks of misadventure and from injecting, so things like also head injuries from assaults and that sort of thing, so things that happen when you're using methamphetamine. In terms of the research, the neuropsychological research at this point doesn't clearly suggest that methamphetamine use after a period of abstinence results in cognitive deficits and acquired brain injury. And we really have to think of other factors that are contributing in the individual's history. So there are modifiable risk factors that we can think about that can actually improve a client's thinking skills. And if we compare and contrast back to alcohol, we know that there's a long history of alcohol use and lots of research has been done. Really, methamphetamine research is still in its infancy. Just briefly, we're going to touch on some of the practical recommendations for your client that might actually assist you day to day, and we're thinking about modifiable risk factors here.
So being aware of the acute and subacute effects of methamphetamine use of cognition, and of course the effects of other substances. So if your client's using benzodiazepines, we know that they're going to be slower, for example, and have poor attention, and that's going to affect their memory. Take the time to really have a think about your client's functioning before they started using methamphetamine. So what did they get up to in school? Have they ever held down a job? And also their mental health as well. So are there other factors coming into play in the client's history that you can actually adapt your treatment and approach with the client based on their history and their mental health concerns. Of course, we look to reduce the harms of use, and we always find it useful to recommend things like sleep hygiene tips, good nutrition, ensuring they have stable housing, and of course other general health factors which all have a massive impact on thinking skills. We're going to throw back to Catherine to finish off the talk today with a revisit of our poll.
Okay, so would people like to have another go at the poll? We'll stop in about 5 seconds. Okay, so what we can see here, I guess, is that at the beginning, 69% of you put yes, that you thought it does cause lasting cognitive impairment. And, you know, I guess we're happy that we've, you know, shifted you a little bit more into the no, not sure zone. It was 4% of you earlier who said no. And I think, you know, this is very important that, you know, we do want to consider the range of modifiable things that are affecting our clients, and just be aware, I guess, of the limitations in the research and drawing very swift conclusions about the relative harms of methamphetamine on your brain. So thanks for listening. What we will do, there's a little bit of info here about our neuropsychology service, and then we'll take time for some questions because I've been seeing some really interesting questions coming through. So we do a range of things. We will do an assessment with clients. We might do a secondary consultation, a bit as I described for Jenny, where we'll talk to you and provide you with support around managing your client. And we do education and training like the webinar today. You can easily find our referral form if you Google Turning Point Neuropsychology, and there's a link there as well. And this is our team with our phone number. So again, you know, you can call us, you can email us, you can send in a referral, and the more you put in on the referral form, the more helpful it is. So I think that we're up for questions, and I believe that Sheridan is going to ask the questions.
Yes, so we're going to come back to me. I'm just checking that people can hear me first. And I'll go through and have a look at, go back to the first question. No one can hear me, okay.
Do you want me to do it? So Sheridan's having a microphone problem, so I'm going to go through some of the questions. Okay, so Kathy asked a really good question, which is how do neuroscientists work out what someone's skills and capacities would have been before their use or injury? So we do this by gathering a range of information. So we look at the person's educational history, their occupational history, and then we have a range of tests that we use which we know hold up to brain injury, in that, you know, they're very well formed skills that people don't usually lose after an injury. And from this we can get an estimate of pre-morbid intellectual ability. So if you've ever got one of our reports, one of the first things that we'll talk about is what we think the person's previous level of functioning would have been, and then everything is compared to that. Going back to our lawyer, you know, if we saw a lawyer and we estimate them to be in the high average to superior range of intellectual functioning, and now they're average, they might be like nearly everybody on the street, but that's a big change for them. So we're always doing it that way. So I hope that that answers your question, Kathy.
Beautiful. All right, so I think I'm back. So first of all, just to say thank you so much to Vanessa and Catherine for the incredible, really, really comprehensive and really informative webinar presentation. So the next question we have is, I believe it was directed to Vanessa, and it's from Emily. And Emily is saying that she just wants to query something that you said. So she's quoting you: slowly escalating doses found to be protective factor against. Could you explain this comment further?
Yes, certainly. So this was back when we were talking about the laboratory studies, and we were looking at slowly escalating doses of methamphetamine being protective. So basically it's protective both against neurotoxic damage to brain cells, but also with the laboratory animals, they do their version of cognitive testing. So it was also protective against some of the cognitive tasks, so object recognition, memory, and there's also a conditioned, it's called a conditioned place preference task. So basically, in a nutshell, protective against neurotoxicity and also kind of cognitive functional difficulties as well.
Thank you. So the next question we have is from Marianne, and Marianne asks, is decreased dopamine due to methamphetamine use? Is it involved in causing Parkinson's? Who would like to answer that?
I can. Yep.
Great.
Thanks, Marianne. So again, so one of the reasons people have started wondering about methamphetamines and Parkinson's is because Parkinson's develops when people don't have enough dopamine in their brain, because the part of your brain that produces dopamine slowly reduces as we get older, and then by the time people develop Parkinson's, they hardly have any left. So some researchers are wondering whether, because methamphetamines affects the dopamine system, people may be more susceptible to developing Parkinson's. But I think if you consider the limitations that we've talked about already, we really don't have a very long lead time. The methamphetamine users, I don't know how old they'd be now, maybe 50 might be the oldest use. So I think this is a question that will become clearer as the current batch of methamphetamine users get older, and then it will become much clearer whether they're more likely to develop Parkinson's. But we really need that longitudinal research and that lead time to be able to see whether it actually happens. So currently I think it's a hypothesised link, one that's not very clear.
Okay, thank you. We've got we've got a few questions, and we'll try and answer as many as we can, but we are slowly running out of time. So another one was from Marianne again. Would you class persistent auditory and visual hallucinations as cognitive deficits in cases where there is no pre-existing history of psychosis?
I can answer that one.
Thank you.
So for the purposes of this talk, we did not cover the psychiatric effects in detail, so psychosis. In fact, there's actually another webinar that's available online by our addiction psychiatrist at Turning Point, Dr. Shalini Arangiri, around methamphetamine use and psychosis, so that's available to watch. But no, we don't actually, for the purposes of this talk, we have not classed that as a cognitive deficit. So we're looking at thinking skills essentially, so things like memory and learning, attention and concentration, executive functioning, so things like impulsivity and planning and reward, and we look at thinking speed and that sort of thing as well.
Great, thank you.
We look at thinking speed and that sort of thing as well.
Great, thank you. So we might just take one more. Can you overdose on methamphetamine, and what is the impact on long-term cognitive functioning with this? Is that clear?
Yeah, I can do that one. So the information on overdose, I guess, is available from the literature that you see and the reports in the media from people who overdose at festivals. And so if you do overdose, what happens is that you can, as we said, have very high blood pressure, very high body temperature, and then your body begins to shut down. So these are the mechanisms of overdose. So you basically go into toxic shock, and this is why people will die from, potentially using some of these drugs that affect the dopamine system. So that is a consequence. But again, if people slowly escalate their use, like the lab rats that Vanessa talked about, then there's potentially a little bit less chance of this. There's one other question I'm very quickly going to answer, which was about the interstate referral I saw there. We are a Victorian statewide service, and it's very hard to do a neuropsych assessment on the phone, but if you've got questions, you can email our neuropsychology team and we can try to point you in the right direction in your state.
Okay, thank you so much. That was incredible information. There are other questions that have been answered, but we do have to stop there because we've run out of time. And what I'll do is if you've asked a question in the chat box and it hasn't been answered, I will receive a printout, and what we'll do is we'll try and answer those by email, and either from the workforce development team if we can answer those, or we will pass those on to Vanessa and Catherine to answer by email. So thanks so much for all of your participation. We wanted to also say, and also we're asking for your feedback as well. So after you've finished, after we've closed down the curtain and the webinar has completed, you'll actually receive an invitation to give feedback. So please do give that feedback. As this is the last webinar for 2018, and we will be running more webinars in 2019, in that feedback, we'd also really appreciate feedback on the kinds of topics that you would like to see addressed. If there's any information or specialised kind of questions that you would like to see offered here, please let us know in that feedback as well as giving feedback on this particular webinar as well, so we can continue to improve and develop these offerings for you. We would like to thank you all for participating. If you are somebody who has a specialised skill or knowledge and you would like to be a contributor, so you'd like to come in and record a webinar for people across Victoria, please also get in contact. I've got my email address there on the screen now, so I'm Sheridan, and also Phoebe's email address. So we're a part of the team in the workforce development team that look at these and start to develop ideas around webinars. So from Sandra is also a part of that team as well. So from Phoebe and Sandra and myself, thank you very much for all of your participation. We look forward to seeing what ideas you've got and what feedback you've got. And yes, please do take a moment to fill in that feedback for us, and we will see you through Webinar World in 2019. Thank you so much, everybody. That was everything? Yeah.